Okay, continuing with two-dimensional arrays, there are some standard algorithms for processing data in a two-dimensional array. One thing you might want to do is process every item in a row. For example, every item in row number 3. If I want to do that, I go to row 3, column 0, then I go to row 3, column 1, and then I go to row 3, column 2. So I've listed the subscripts for each one of those array accesses down here. 30, 31, 32. Okay. Notice that the row number remains the same, and what changes is the column number. In a way, this is basically the same algorithm as processing a one-dimensional array. If you take a slice, whether it be a row or a column, out of a two-dimensional array, it's basically what you're left with is a one-dimensional array. You still need the two subscripts, though, but the algorithm is exactly the same. So to process a row, just specify the row number, keep it constant, and then go from the first column to the next column and keep on going until you get to the last column in the array. Okay, so we are going to look at some code here to do that. So I'm going to copy this code. I'm going to switch over here to our arrays program, and I'm going to paste it in. So the name of the function is displayStudent. It doesn't return anything. We're writing this in a console program, so we have to start off with static. We're going to pass in a two-dimensional array called score. We're going to pass in the number of students, and we're going to pass in the number of tests. And in this function, we're going to ask which student they want. And we are going to get the number of the student from them, and we're asking them for a number from 0 through number of students minus 1. So we're asking them to think in terms of computer array indexes rather than people array indexes. And then what we do is they give us the student number, and that's going to remain the same. But what's going to change is we're going to start with column 0. We're going to add 1 onto it, go to column 1 and column 2 in this case. And then we're going to write out each one of that student scores. And then at the end, we're going to ask them to press, actually, we don't really need that because we've got that on the end of the program here. So I will clean this up a little bit by getting rid of that. Okay, now let's run this, keeping in mind that we're going to enter a number from 0 through 19, not a number from 1 through 20. So let's go ahead and run it. We will skip the lookup score. We don't need that. All we want to do is test this one. And in order to test this one, we have to call displayStudent. So let's put in a call here to the function displayStudent. And we're going to pass in the score, we're going to pass in max students, and we're going to pass in max tests. And a semicolon on the end. Okay, let's run it. And it wants to know which student, and I am going to type in student 0. And it should give me the 3 test scores for that person, which should be 10, 11, and 12. I'm sorry, 11, 12, and 13. I'm not very good at jumping back between 0-based and 1-based. So let's make this more realistic like we did on the last example. And instead of asking them to type in a number from 0 to 19, let's have them enter a number from 1 to 20. And we'll take what they give us and we'll subtract 1 from it to convert it back into computer array index values. Okay. So now, since we're using a 1-based array rather than a 0, at least we're looking at it that way, I'm going to type in 20. I wouldn't have been able to do that with the previous example because I would have been off the end of the array. But in this case, it's going to give me row 19, and first 2 digits here are going to be the row, and the last digit is going to be the column number. So it is correctly looking up. So this is a very simple algorithm. Once you know what the row number is, which is student here, then it's just this algorithm, which we've seen many times before. The only difference here is that instead of just printing out score sub C, we've got to specify the row we want first. But otherwise, it's the same algorithms we had for processing a one-dimensional array. Okay, that takes care of that algorithm. We'll stop the video there.